The Simatic HMI, Human-Machine Interface, will take you through Phase 4 of the life cycle model of automation systems, operation and maintenance. Simatic HMI systems are used for operator control, monitoring, reporting, archiving and logging. They accomplish these tasks by dynamic process screens that visualize the automation process and allow operator interventions to control it. System or process events are shown as message lines that contain not only the message text, but also extra information that is important for a fast response. Current data and messages are archived so that past process states can be reconstructed. The history can then be displayed as a graph or table or printed as a report. A wide range of further applications opens up when the HMI is connected to a company's IT and business world. For instance, the corporate management can access and evaluate selected process data, or diagnostics and control of the plant are performed from a remote control room or a mobile service. Siemens offers a variety of operating devices, both for machine-orientated control and monitoring and for process visualization. The products offered range from small-size operator panels to mobile variants and to PC-based systems. In terms of software engineering, Simatic WinCC Flexible is the configuration tool for all panels and PC-based standalone systems. Besides, Simatic WinCC offers a PC-based process visualization solution that is scalable from standalone to redundant multi-terminal systems. Both HMI systems have one thing in common. They can be integrated into the Step 7 configuration. The following scenes will show you the resulting benefits. The Simatic Manager provides an engineering suite that allows you to manage not only automation components such as controllers, I/Os or bus systems, but also HMI systems. Its integration into the Step 7 project provides a threefold uniformity in terms of configuration, data management and communication. This means a wider scope of functions for the HMI solution. For example, because Step 7 messages are supported. At the same time, it means less configuration effort and consequently fewer potential error sources. The Step 7 configuration is stored by the Simatic Manager in a common database. When an HMI application is integrated, either a WinCC Flexible or a WinCC project is created that references the Step 7 project. All relevant parameters are taken from the Step 7 database. When the HMI project is now further edited with the appropriate configuration tool, the connection parameters, symbol information and messages are ready for use as a basis. Now take a closer look at how HMI configuration is made easier by integration into Step. The link between the operating device and the automation system is limited mainly to the physical connection. All necessary drivers have already been installed with the Simatic HMI software. The system communication does not need any special blocks in the controller's user program. The connection parameters have been taken from the Step 7 database. Therefore, no extra configuration is required to connect the HMI system to the network. Let us now look at the access to the controller's memory areas and thus to the process. In the HMI system, data is transmitted by tags. Internal tags, as their name implies, are only valid within a specific HMI project. Process tags, on the other hand, do the real mapping of the controller's memory. The integration into Step 7 allows the allocation of the tag addresses in a symbolic. The use of Step 7 symbols provides more clarity and reduces the risk of input errors. WinCC moreover allows the marking of operands as HMI relevant in the Step 7 project. The corresponding process tags are then created by WinCC without extra effort. With additional attributes such as limit values, you can assign further properties to the tags in the HMI project. Let us now look at some major fields in which process tags are used to dynamize process screens. The graphics editor of the Simatic HMI software provides the project planner with a large number of predefined functional objects whose appearance can be customized. Objects are dynamized by links with tags and used for visualization of the process and for operator control. The tags can also be pre-processed in scripts. For instance, logical combinations and arithmetic calculations can be performed. Event-triggered or cyclic archiving of tags is possible to track process value histories. Once tracked, the sequence of process values can be output in graph or table form. Let us now turn to another major functional mechanism, the message system, and find out how the benefits of the integration into Step 7 are brought to bear. Like other data, messages are output in process screens using special objects. Generally speaking, the message system is used for display, logging, and archiving of system and process states. Important additional information makes it easier to quickly detect, localize, and eliminate errors in the process execution or within the automation system, so that plant downtimes can be avoided or substantially reduced. One way to generate messages is the bit or analog message procedure, which is configured in the Simatic HMI software. If it detects that a binary tag has changed status or that an analog tag has exceeded a limit value, the HMI system triggers a message and has it output with a timestamp generated for it. With this procedure, the HMI system handles both the detection of events and the management of messages. Because of its integration into Step 7, the HMI system also supports Step 7's comfortable message number procedure, which we will present to you in the next scene. In the message number procedure, the automation system assumes all reporting tasks, which has a number of decisive advantages. Two classes of messages are available: system-specific messages for system monitoring and user-defined messages for process monitoring. Diagnosable modules are able to trigger system messages if required. The texts of these messages are predefined in the system and correspond to specific events, such as an access error. With user-defined messages, on the other hand, the project planner determines the event that will trigger a message and the message text. Three types of user-defined messages can be distinguished. Diagnostic messages are best suited for monitoring the process execution. Block-related messages indicate process state. They can contain accompanying values that were recorded at the time of the event. The message text may vary depending on the accompanying value. With an S7-400 CPU and Simatic WinCC as HMI system, it is also possible to configure symbol-related messages for monitoring Boolean operands directly in the symbol editor. All these message types basically work on the same principle. When the messages are configured in Step 7, the texts and attributes are stored in the common database and passed on to the operating device during the transfer of the HMI relevant data. At runtime, a system internal or user program detection routine detects the event to be reported and calls a special system block to organize the message. The system block transfers the specific information, such as message number, status, and timestamp, into the controller's message. The S7 communication system now generates a message telegram and sends it to the operating. Here, the internal diagnostics handler adds the texts that correspond to the message number and displays the message. In comparison to the bit or analog message procedure provided by the HMI system, the message number procedure in Step 7 has, for instance, the following advantages. The controller generates the timestamp right after the event. Messages are only transmitted if an event actually happens. Without such an event, they do not add to the bus load. Since messages are centrally managed in the controller, they have the same status even if they appear on more than one operating device. All these advantages allow high-performance system and process diagnostics. Additional support for the generation and handling of user-defined process messages is provided by the Simatic diagnostic tools S7P Diag and Pro Agent, which offer, for instance, predefined diagnostic screens. Last but not least, we will show the screens of a real-life project to give you an idea of how all the above tools interact. On the engineering station, which may be, for instance, a Simatic programming unit, Step 7 and WinCC Flexible are installed. The Simatic Manager at the heart of the system manages a Step 7 project with an HMI project integrated into it. The operating device has been integrated into the configuration of the system communication. The common database of Step 7 finally includes, besides the connection parameters, also the messages and the symbol declaration shown here, and makes them available to both the controller and the operating device. Let us now turn to the HMI project, which can be opened directly from the Simatic Manager in WinCC Flexible for further configuration. The connection parameters defined in Step 7 are available at once and only need to be set to active. Changes made later on are automatically updated. The Step 7 symbols can be used for creating the process tags. The system then automatically adopts their data types and addresses. The tags are connected to the graphic objects in a process screen by means of a comfortable designer tool. Extensive object and function libraries are provided to clearly visualize the process. After the download of the appropriate project paths into their target systems, these can be started and therefore be made ready for operating.